In example 4, we're going to be working with some arithmetic sequences. In part A, an arithmetic sequence has a formula of a sub n is equal to negative 8n plus 147. We want to know the position of the term with a value of negative 181. So a sub n is going to be negative 181, and n will be the position of that term. So we'll subtract 147 here. Negative 328 is equal to negative 8n, and we'll divide by negative 8. So we'll do 328 divided by 8, and it's 41. So it's the 41st term. In part B, we're going to consider the arithmetic sequence in which the values of the certain terms are unknown. We need to figure out which values go here. If we think about it, we're going to have to add D once, twice, 3 times, 4 times, and 5 times. So we want to take 33 minus 3 and divide it by 5. That's 30 divided by 5, which is 6. That should be our common difference. So 3 plus 6 is 9, plus 6 is 15, plus 6 is 21, plus 6 is 27, plus 6 is 33. We could back up 6, and the first one is going to be negative 3. You could guess and check here with this one, but I think this is a more mathematical and a quicker approach. We're asked to find the common difference of this sequence, and the common difference is 6. A few more examples in this one. Part C, the arithmetic sequence has some missing terms. Fill in all the blanks for each sequence. So halfway in between 8 and 17, if we do 8 plus 17 divided by 2, that'd be 25 divided by 2, which is 12 and a half. So we know that 12 and a half will go here. D is 4 and a half, so we need to add 4 and a half to the 17, which is 21 and a half. We'll go backwards. 8 minus 4 and a half is 3 and a half. 3 and a half minus 4 and a half is negative 1. Part D will consider the following sequence: 250, 241, 232, and 223, and so on. What is the value of the 31st term of the sequence? I think we'll try to write a rule here for this one, and then use the rule to find the 31st term. So the first term is 250. D looks like it's negative 9, so we could write plus negative 9 or minus 9, it's fine, times n minus 1. I'm going to leave it like this, and all I'm going to do here is just substitute 31 in to find this value. We'll use our calculator for this one. So we've got 250 minus 9 in parentheses, 31 minus 1. You can just type it in just like that. Make sure you utilize your parentheses. And it's negative 20. That should be an A here. It's a little bit of a long tail. Part E, 88. What is the value of the 88th term in this sequence? So for this one, n is 1, and you get a value of 2. When n is 2, you get a value of 4. When n is 3, you get a value of 6. And when n is 4, you get a value of 8. All you do is just double n. So doubling 88, you get 176. So the 88th term is 176. One more example. Got part F to do here. Just as Julian finished his homework, he went to feed his fish and accidentally dropped his homework in the fish tank. He was working on the patterns of numbers, and the last number in the 4 of the patterns was washed away by the water in the fish tank. Julian needs help recreating his patterns. Find the next 2 terms in each sequence and write a rule that describes each. Okay, so in this one, we're going up by 2 each time. So we need to write the next two terms, so that's going to be 9 and 11. The rule we'll use our formula here. A sub 1 is 1. D, the thing you're doing each time to each term, is 2, adding 2. So it's going to be 1 plus 2n minus 1. And negative 1 plus 1 is 0. So we should just have, oops, that's a 2 here. My fault, didn't do the distributive property. So we've got 2n, and then 1 minus 2 is negative 1. This next one we're adding 5 each time. So the next term will be 33, and then after that will be 38. We'll write a rule. The first term is 13. D is 5, what you're adding each time. We'll do the distributive property. And we'll write that here. So I wrote the 5n first. 13 minus 5 is 8. This sequence we're subtracting 3 each time, so the next term will be negative 8, or negative 5 minus 3. Negative 8 minus 3 is negative 11. To write the rule, the first term is 7, D is negative 3. We'll do the distributive property. We get a sub n to be negative 3n, and then 7 and 3 is 10. With the last one, it looks like we're adding 7 each time. So this term will be 6, and this term will be 13 if we add 7. The rule will be just like this. So we'll do the distributive property here. And we'll write our rule up here. 7n. Negative 22 minus 7 is negative 29.